Hi, this is Dr. Rami. Today I'm going to talk about the digital twins fundamentals, the importance of such technology, how this technology is changing the landscape of different industries, how we're going to use this technology, how to build this technology in a proper way, and what is the main definitions and main components of such technology. But first, allow me to introduce myself. My name is Dr. Rami Shaheen. I'm international subject matter expert in AI and future management tools. Have the most selling book in Middle East for AI and future management tools, being involved with different governments and industries in using the technology of AI and future management tools, including the cognitive digital twinning, uh, starting from UAE, Jordan, uh, Turkey, Egypt, Denmark, Japan, Bahrain, some other countries develop different solutions, especially in military and smart manufacturing for different countries and different organizations. Has been involved in putting the standards of digital twinning for the world. Awarded as the most influential AI and future management tools consultant in Middle East. Now, let's take a look on what we're gonna learn in our cognitive learning journey. To understand, we will understand the meaning of digital twin and the basics behind this technology, how this technology is changing the context of organizations, how it changed the definition of efficiency and effectiveness, why the world is changing and resetting in the way we are thinking about productivity in general. We'll emphasize on the digital twin platforms, ecosystem, business context as well. We'll forecast the new trends of digital twin, and we'll talk about digital threats. First, we need to understand now what is the digital twin and what's the basic behind this technology, and how we can build this technology in general. We need to know that until recently, the digital twin and the way and the massive amount of data we are trying to deal with such data is often elusive for enterprises and organizations due to different limitations in digital technology capabilities, as well as prohibitive computing, storage, and bandwidth costs is another factor that changed the way we are dealing with such technology. Such obstacles, however, have diminished dramatically in recent years. The whole landscape is changing. It went significantly to lowering the cost and improve the power and capabilities of computers, and exponentially we reach a point of exponentially changes that can enable leaders to combine such informations with technology, which we call it the IT, information technology. And on the same hand, we were able to use these technologies into our day-to-day operations, either to improve it or to collect this data with a minimal, and we call it the OT, the operation technology, which enable us to create the new use of a new technology that took a place these days with the great reset that taking place in our life, which is the digital twin, a copy of your existence in the physical layer or physical pillar that reflects all the daily and routine activities into the digital pillar and virtual pillar, which will give a real time impact on any data and activities that took a place in our ecosystem. As simple as that. We are changing, we are evolving. Our mindset, the way our companies work, the way our company deal with data is different now. And here the importance of digital twin came to the surface, and we start thinking about a right solution that will change and will help us to deal effectively and efficiently with these three pillars. Now we are talking about the productivity growth, the new aspects of checking and monitoring the growth, such as GMP, for example. We are talking about the short-term debit cycle that came from the expansion, recessions, and booming in certain industries. We are talking about the long-term debit cycle, which manage the monetary system and the new world order, the new political matters that help or change the way people deal with each other and with the wealth distribution. All these factors are external forces that change the importance of digital twin for us. Will not forget that after such a period of time, we are into the eight D's of the new economical order, which is disruptive, digitalized, dematerialized, democratized, demonetized, and deceptive. These are changing how we deal with the climate change, how we deal with the six mass extinction period, with the new economical era, with the way we deal with the cloud, with the big data. All these things came to a point that we need a tool that will deal with this exponential disruption that took place in our organizations. In order to do such a thing, we need to consider the environment. We need to consider the way we are dealing with our cognitive new environment. So we have a three main pillar that uh, built this technology that we are already discussing right now, the digital twinning. So we're gonna start with the physical world, we have the digital world, and we have the virtual world, which has been newly came to the surface of technologies and communities. So if you connect the physical world with the digital world, you will have a cyber physical system that will integrate the data into a real time manner. And this is very important. And on the same hand, if we connect the digital world with the virtual world, we'll be able to reflect the activities that we are getting from the real time data through different innovations. And it will help us to sort out different challenges and matters. If we connect the virtual world with the physical world through different technologies, we'll have a proper reflection on a real-time data that will help us to achieve different results, starting from redefining the customer journey, achieving operation excellence, and achieving a growth to organizations and industries and even to countries. Enhance the smart automation service for our industries. All these things came to the surface of technology to change the way we are dealing with this technology and to let us re identify our cognitive environment in a way that will draw for us a set of technologies with a set of priorities. Now, with these changes of environment, uh, we need to understand that we are working hard to achieve an accelerated, livable, workable, and sustainable world that will come along between through the connection between physical, digital, and virtual pillar, which aligned with the SDGs, what we call it Sustainable Development Goals. And we aligned with the goal number 11, Sustainable Cities and Communities, with goal number 12, Responsible Consumptions, and with goal number 13, which is the climate actions. Now, because of this cognitive environment changes, we came along to the importance of having a system that will reflect the data, innovations, and activities of our daily routine jobs and activities, uh, and will help us to draw a conclusion. So, all these things will work together to achieve a better, livable, workable, and sustainable life for our daily and routine activities on the organization level, on the community level, and on the personal or individual level. So there is for such technology, for such challenges, digital twins platforms, ecosystem, and business context came to the surface to solve out all these matters and to deal with this cognitive environment. So, why is the digital twin so important? And why you should, or our organization should, consider it? That digital twin can allow companies to have a complete digital footprint of their products from design and development through the end of the product life cycle, which is what we need to deal with this cognitive environment. In turn, we may enable the system and the community to understand not only the product as a design, but also the system that built the product and how the product is used in the field with the creation of the digital twin. Companies may realize significant value in the area of speed to market with a new product, improve operations, and reduce defects. And all of this will come along with emerging a new business model to drive the revenue either for country or for organization or community. It's very important to understand that digital twin will give us a new set of solutions that will improve radically the operation level of different sectors and industries with adding a very high level demonstration of what we are doing in our business model. The digital twin will always detect any actions that will be taking place in the physical pillar, reflected into a digital information, which will help us to have innovations and solutions on the virtual pillar. Enabling the companies and physical to detect the physical defected outcomes. It will help us to increase the level of accuracy, we call it the degree of accuracy, to design a better product, and ultimately better serving the customers or building a new level of customer happiness. With this smart type of architecture designs, companies may realize the value and benefits iteratively and faster than ever before. And this is very important. It can be daunting task to create a digital twin for a company with all the information and operational complexity that we have. The key could be to start in one area and develop the value through each and every area of the business, and to continue and sustain the development to achieve different aspects and goals. Enterprise should understand first the definition and approaches to develop the digital twin in order to avoid being overwhelmed, if you allow me to say, with the way we are dealing with this technology. If we want to define and simplify the definition of such technology or digital twin, it's a way of creating how to deal with it's a way that we create to deal with value and to deal with data and to deal with the application layer of the digital transformation. It's very important for any organization to understand the digital twinning planning process, and it's very important to understand how this smart architecture will move and change the way we are dealing with this technology. So we can start by a particular model that will help us find the expression through five enabling components, such as sensors and actuators from the physical world, as we said. So we will get whatever data we required from the physical world through integration of the data and analytics or previous analytics and the continuous updated digital twin applications, integrate them together in order to scale it out and be able to imagine and assess the process opportunity of the digital twin. We don't need to forget that what the element constitute the high level of the transformation is the sensors. Sensors need to be distributed throughout the whole system, the whole ecosystem, to create the signals that enable the twin to capture operational and environmental data uh, pertaining to the physical. So this is a very important part in the identification mode. So which will help us to draw a pilot of the digital twin that will take the whatever information we extracted on operational level, environmental level, in particular, to a new real world operations and environmental data that can be aggregated and combined together to build the enterprise map. Enterprise map where we can have a different pilots of digital twin to stabilize the solution or reflection of digital twin that we have, and to build for us the BOM, the bill of materials that taking in place in different pillars of the digital twin. It's very important to have the enterprise system well defined, designed with specification, and to be stabilized. And this is the most important part when we stabilize the solution, where we have the specs in a place stabilized to be able to scale the data feeds that we are getting from different nodes. Then we'll start adding additional area and the processes on phases to help us and to help the sensors communicate with each other, which can be placed in the digital pillar of our golden pyramid that we discussed in the previous slide. Through integration, we need to include the edge computing, communication interfaces, and we don't forget the security, which is one of the most important layers between the physical world and the digital world. And for sure, vice versa. So it's going between physical and digital and physical. Through this iterative cycle or or implementation cycle, we'll be able to learn how the digital twin will be able to connected and integrated with other technologies as well, such as metaverse, such as AI, smart big data, and so on. We'll not forget in the scaling phase, we need to have the analytics techniques, or what we call it the direct data platforms. A platform that will be able to predict the results and the facts, and will be able to draw the relation through AI algorithms of the physical real world on a real time impact. And such algorithmic simulations and visualization routines are used by the digital twin to produce insights at the end. These insights will be reflected into actions, and we'll not forget that if you finish the scaling phase without having a proper action or reflections, then there is something missing in your ecosystem. Combining such actions should be with a few constraints. One of them is the real-time impact of your digital model, or what we call it the digital twin. After you have such real-time impact actions and insights, you need to reflect these things to objectives, to measurable objectives, in order to monitor the progress the return on investment and return on value for optimal conditionings and best solution that come along with various dimensions that the digital twin provide to us. Uh, if we close this ecosystem in different parts and different pillars of the environment or the cognitive environment, we'll be able to achieve the business optimization. Uh, and with business optimization we have always a proper plan to minimize this risk, to minimize the error rate, or we call it the logical error rate, and the opportunity of will optimize the opportunity of saving cost, will improve the quality, will achieve a greater efficiency that should be identified, as we said in the previous phase when we connected to the objectives. We talked about the sensors through different phases. Now the actuators should be an action that warranty the real world efficiency with the digital twin produced actions by the actuators, subjected to the human intervention, which trigger the human intervention that trigger the physical process in general. If we want to sum up, we'll come along with different facts, that we're gonna start with imagining the solution, to identify the solution that will be suitable for our type of data and processes we have. We'll start piloting what we have, and then we'll standardize and stabilize the maturity or the system, and then we're gonna implement some additional parts to enhance and improve the results. Then we'll start monitoring by implementing such technology into our cognitive environment. So guys, the creation of digital twin encompass two main components that is important for us, which is the designing of digital twin process and information in the product life cycle, from the design of the assets to the field use and maintenance of the assets in the real world. The second part will be the creation of the enabling technology to integrate our physical world with our digital world in a real time flow of sensors and data, which will cover the operational and the transactional information from the company core system, supported by the edge system, as we call it, the conceptual architecture of digital twin. We'll not forget that if we want to build a holistic plan, we need to go into three phases: digital connectivity, digital reengineering, and digital results or digital operationalization. Uh, it's often very important to structure the information in a very usable way, either in point one or point two, which will always create a canonical data model that can be important for the organization, and it will be a common enterprise standard data structure. It enables different systems and application to connect and exchange enterprise information in general. The whatever we are talking about, start about the conical structure, to the re-engineering to operationalization. These things are always connected as a matrix together to achieve the requirement of digital twin. It can allow the system to communicate in a simple, agreed format. And this is very important to ensure a smooth transformation cycle for our ecosystem in general. By the way, such activities might reduce the amount of information that can be stored in the system or outside the system in a particular places and technologies. And this can eliminate the need to manage a large master data structure, which is very important for us in terms of cost and in terms of efficiency. And they are both working to achieve an effective ecosystem or cognitive environment, which we call it the digital twin. Uh, on the same hand, it will allow companies to use the digital twin in multiple ways with more procedure agility, or we call it the flexibility to continually update the digital twin as an integrated enterprise, but not as a burden, a new burden for the enterprise. And this is very important part that should take place when we create the digital twin. So we need to wrap up. We need to cluster whatever we are doing. We need to work on different layers, and then we need to have the data model simplified in order to help us to exchange the data into the three main pillars as we explained in the pyramid. So uh, I thought we need to talk in deep about what we need to have in general, how we gonna achieve that by a step-by-step model that will help us to connect our physical process and physical aspect into our digital twin with a with the third pillar of virtualization of virtual pillar that will work together in order to achieve contextual information that will help us to build certain acts and actions on a real-time basis. So we'll start by creating, which in which through this step we'll create a step encompasses outfitting the physical process with the merit sensors that major critical input from the physical process and its surroundings. The measurement by the sensors can be broadly classified into two main categories, and these categories will help us to understand the type of data that we have. On the same hand, it will help us to aggregate whatever we have on a later stage to reflect the digital twin. So we'll start by the operational, we call it the operational measurement pertaining to the physical performance criteria of the productive assets, including multiple work progress, such as tensile string displacement, color uniformity, for example, and such things. The second attribute will be environmental or external data affecting the operations of a physical assets, such as temperature, biometric pressure, moisture level. The measurement can be transformed into a secure digital messages using encoder and then transmitted to the digital twin. Or we can build, and this is a new technique, we can build a blockchain system that will work along with these data to provide a secured and trusted source of data. Then the signal from the sensors might be augmented with the process-based information from systems such as the manufacturing execution system, enterprise resource planning system, CAD models, supply chain systems. This would provide the digital twin with a wide range of continual updating data to be used as an input for its analysis. Then we'll go to the second pillar. And in my book, I talked a lot about the communication for such technology. The communication step help the seamless real-time bi-direction integration and connectivity between the physical process and the digital platforms in general. Uh, and we not forget the network communication. Uh, One of the main radical changes that have been enabled the digital twin to, so it compromises three primary components. like edge computing. The edge interface connected sensors and processes signals and data from the near source and passes data along to the platform. This serves to translate proprietary protocol to more easily understood data format, as well as reduce or radical reduction of network communication. Major advances in this area have eliminated many bottlenecks that have limited the viability of a digital twin in the past. And we will not always forget that edge computing helped the network efficiency to change radically in different aspects and pillars of the communication interfaces. So the communication and interfaces help transfer information from the sensor function to the integration functions. Many options are needed in this area, giving that the sensor produce the insight that can, in theory, be placed at most of any location depending on the digital twin configuration under consideration. Inside factory, home, mining operation, parking lot, among other the different applications. We will not forget on top of that we need the edge security. A new sensor and communication capability have created a new security issues, and this is very important, which are still developing and still revolving. The most common security approaches are to use firewalls, application keys, encryptions, and device certifications, in addition to some blockchain techniques. And some very important blockchain protocols play an essential role in the transformation of digital twin. The need for a new solution to safely enable digital twin become more pressing as the assets become an IP enabled. So if we'll be able to change and transform our assets into an IP enabled assets, it will help us to go and aggregate informations and have a ingestions into the data repository to process and prepare for analytics for different assets. This is one of the most important role of data aggregation, which is the third phase that come along in our diagram. By the way, the data aggregations can be sometimes done in the cloud, or we can do it on the prem. The technology domain that power data aggregation and processing have evolved tremendously over the last few years in a way that allow designers to create massively scalable architectures with greater agility and at a fraction of the cost in the past. Once we have all these aggregates in a place, either on prem or in a cloud, we'll be able to analyze such information and data to build an insight that is visualized. Usually, data scientists and analysts can utilize advanced analytical platforms and technologies that will help to access these devices and to develop iterative models that generate insights and recommendations or actions which will guide the decision maker over making and or it will support the decision making cycle. By the way, in the governance matter of such solution, we call it the level of augmentation and operationalization, which is two main pillars that form the governance for this solution. Uh, the third part of or the next part of our solution is building the insights which presented through dashboards, visualization, center of excellence, highlighting unacceptable differences in the performance of the digital twin model and the physical world analog in one or more dimensions, indicating areas that potentially needed to be investigated and changed or developed in a way or another. This will draw us to a new way of actions or acting toward certain information and insights. This phase is only an actionable insights from that has been taken and considered from the previous step uh, of our physical assets that might impact the digital twin results. For sure, any insight will go through different phases of decoders and fed into the actuators on the assets process, which are responsible for the movement or control mechanisms or updating the back end system that controls supply chain and ordering behavior, for example. All subject to human, all subjected to human intervention, which can be again governed by level of augmentation by the human. This interaction or action will close the connection loop between the physical world and the digital world in general. Uh, we will not forget that in order to work on such phases, we need always to standardize the security for data and connectivity in order to achieve the required results. To So it compromises three primary components like edge computing. The edge interface connected sensors and process historians processes signals and data from the near source and passes data along to the platform. This serves to translate proprietary protocol to more easily understood data format, as well as reduce or radical reduction of network communication. Major advances in this area have eliminated many bottlenecks that have limited the viability of a digital twin in the past. And we will not always forget that edge computing helped the network efficiency to change radically in different aspects and pillars of the communication interfaces. So the communication and interfaces help transfer information from the sensor function to the integration functions. Many options are needed in this area, giving that the sensor produce the insight that can, in theory, be placed at most of any location depending on the digital twin configuration under consideration. Inside factory, home, mining operation, parking lot, among other the different applications. We will not forget on top of that, we need the edge security. A new sensor and communication capability have created new security issues, and this is very important, which are still developing and still revolving. The most common security approaches are to use firewalls, application keys, encryptions, and device certifications, in addition to some blockchain techniques. And some very important blockchain protocols play an essential role in the transformation of digital twin. The need for a new solution to safely enable digital twin become more pressing as the assets become an IP enabled. So if we'll be able to change and transform our assets into an IP enabled assets, it will help us to go and aggregate informations and have a ingestions into the data repository to process and prepare for analytics for different assets. This is one of the most important role of data aggregation, which is the third phase that come along in our diagram. By the way, the data aggregations can be sometimes done in the cloud, or we can do it on the prem. The technology domain that power data aggregation and processing have evolved tremendously over the last few years in a way that allow designers to create massively scalable architectures with greater agility and at a fraction of the cost in the past. Once we have all these aggregates in a place, either on prem or in a cloud, we'll be able to analyze such information and data to build an insight that is visualized. Usually, data scientists and analysts can utilize advanced analytical platforms and technologies that will help to access these devices and to develop iterative models that generate insights and recommendations or actions, which will guide the decision maker over making, and or it will support the decision making cycle. By the way, in the governance matter of such solution, we call it the level of augmentation and operationalization, which is two main pillars that form the governance for this solution. Uh, the third part of or the next part of our solution is building the insights, which presented through dashboards, visualization, center of excellence, highlighting unacceptable differences in the performance of the digital twin model and the physical world analog in one or more dimensions, indicating areas that potentially needed to be investigated and changed or developed in a way or another. This will draw us to a new way of actions or acting toward certain information and insights. This phase is only an actionable insights from that has been taken and considered from the previous step uh, of our physical assets that might impact the digital twin results. For sure, any insight will go through different phases of decoders and fed into the actuators on the assets process, which are responsible for the movement or control mechanisms or updating the back end system that controls supply chain and ordering behavior, for example. All subject to human, all subjected to human intervention, which can be again governed by level of augmentation by the human. This interaction or action will close the connection loop between the physical world and the digital world in general. Uh, we will not forget that in order to work on such phases, we need always to standardize the security for data and connectivity in order to achieve the required results. This will open a door for a very important definition. We call it the digital ubiquity. Industrial Internet is based on the newfound ubiquity of digital connectivity. Most information work is already digitized, and we all know that it happens through the connection of between laptops, mobile devices, working environment, and so on. Now, with the growth of Internet of Things and with the growth and need of a new aspect in our cognitive environment, the pervasive deployment of the digital twin is extending digitizations and connectivity to previously analog tasks, processes, and machine and service operations. Moreover, virtually limitless computing power is available at a very low cost through the cloud computing. The combined impact of all this, both established and startup players in every industries are being forced to compete in a new way, and to work with the new business models, and to think with the digitalization in different way. And this will change the future trends of digital ambiguity through different digital threads. So, which will draw for us at the new definitions of digital twins and digital threads, which can be fundamentally identified as a digital profile of the historical and current behavior of a physical object or process that help optimize business performance. But the digital thread is a continuous, seamless strands of data that connected with each and every stage of the product life cycle, from design to build and in-field usage, to provide a feedback on different aspects and channels through which data is moving and traveling from phase to another to build a conclusion. This ready access, modeling, and analysis are what create the ability to model production and drive efficient supply chain communication. When one thinks about the digital twin to happens in one of the phases, it will take us to living a phenomenon, model of non-static process that work to achieve certain purpose of optimizing the business performance. uh, it's a large measurement and a large major that will enable our digital twinning to fulfill purposes of the business models, to provide the kinds of data that the twin needs to perform an analysis and building insight phase. In that sense, the digital twin get its life in part from the information that the digital thread provides. The insight of the digital twin in turn may cause a change in a product design or manufacturing process to alter the digital thread for a future iteration of the object under considerations. And this is very important connections that will connect the digital twin with digital thread in order to build a future trends in general. Now, a pressing concern for possibly any company that start on the digital twinning journey or on the cognitive environment journey, they start to digitize to show the ability and benefits they can realize from such a new environment. And its investment in creating digital twin will be connected to the differentiation advantages and the value advantages to outlead the market space and to improve their revenue in general. But we need to consider a few things: that how many changes in the company we will require to operate and conduct in in the business itself to build the business value. And this is very important. In the past, I believe creating digital twin was costly, and we know the limits and limitations. We already discussed the limitations and benefits. On the same hand, we get with emerging this cognitive environment into our ecosystem. But with the increased favorable storage computing cost, number of use cases that has been developed, and possibility to enable this digital twin have greatly expanded and implemented in different industry, which fostered the transformation in the digital twinning, and in turn it drive the business values and in sector values to go into the out compete level, and make the competition irrelevance with other similar companies who don't have such cognitive environment, and it led the service and product innovation in these particular companies. Um, which reflected on the strategic performance layer and the marketplace dynamics, including the improved long-lasting product performance, faster design cycle, potential of a new business revenue, better warranty cost management. These strategic issues, among others, can be translated into this cognitive environment, and into can be reflected on a specific application that might afford the broad business values and the digital twin in general. As you can see, the gatekeeping or the gatekeeper process from the for the competitive rivalry to the party competitive parties and the competitive dynamics can be controlled through implementing a proper digital twin, which will help to position the organization into the outperform. For example, if you have a telecommunication company, it will help you to position your telecommunication company among the outperform, outcompete, and outlead, to build a value advantage for your ecosystem in general. And this is one of the main factors that will help us to build the digital twin and digital thread and connect it to each other. Now, to build a cognitive IoT system or to build a cognitive digital twin, we need always to use a proper, highly complicated, and a decision support system that will help us to do this decision and to change the presence of our ecosystem in general. And here we are talking about using AI or extreme machine learning in the transformation of any organization or industry into the cognitive IoT. Here we're gonna use the one of the main tools and maturity assessments that help the organization to implement the cognitive IoT with and change the required changes, or take the required changes in their environment through using AI. This tool called AMA, Artificial Intelligence Maturity Assessment, which is an American company standard, and we use different aspects to be studied and analyzed in order to build a proper and efficient, responsible cognitive IoT. So this tool have four main components. We have the strategy of the organization or industry or even country, the finance and infrastructure, the procedure agilities, and business enablers. We put these pillars together into this extreme machine learning mind. The mind will give you three main pillars: a ready strategy to transform the organization through using cognitive IoT. It will give you a set of corrective action to reach the mature enablers required to implement the IoT solution, and it will prioritize the future management tools that required for your organization. As you can see, this solution or AIMA helped us to accelerate the transformation for our digital twinning in general. But there is a one missing part before going into the implementation and to start implementing the different phases we discussed. We need to have a digital twin architecture that synchronize directly with a clear mechanism with the real world, and built according to the required security, trust, and governance for such transformation, with a proper representation system of the virtual environment. So it can be fairly complex, since assets and twins must have corresponding information model to the required degree of fidelity, and must maintain synchronization with each other at an appropriate frequency. In addition, a system may include multiple twins and assets interacting with each other as well. This includes these include a data model, AI and simulation components, synchronization mechanism, application interface, a network and software platform, and the support for security and trustworthiness of our system. As you can see, if we'll take each and every component and discuss it, we might take a long time. So I will briefly explain the components of each and every part. If we're going to talk about security, trust, and governance, we are talking about main five pillars, which are privacy, security, safety, resilience, and reliability. These come under a form of four main pillars of governance, which is level of human involvement, stakeholders' needs, operationalization, and internal measures and structure. On top of that, we'll talk about the management and automation for IT/OT platforms with the APIs and all the related matter and components to form this effective architecture. On top of it, we'll have a virtual representation of the service interface and the modeling to build the insight as we discussed before. Then we'll integrate it with visualization, analytical, and we might integrate it with other service or other digital twin. It will come along with the application on top to visualize the action in general, which will support the digital twin system and will support the synchronization and mechanism with the real world. And a top notch, this is the digital twin in general. Now, we talked about how to accelerate the transformation through AMA. We talked about the business architecture and how it took place. And now we need to consider the value that we need to achieve in order to measure the effectiveness of our digital twin. We have a different category of business values. We have the category of business value and the potential specific business value that we can achieve through the digital twin. We have the quality, cost and services warranty, operational cost or operationalization. We have retention and serialization, cost and lead time of certain new products, a new revenue growth opportunity for sure in general. Um, with equality, we always consider of improving the overall quality of our system. We always talk about detecting the defects or predictive maintenance, control quality, and able to issue or diagnosis analysis, cost and services. We have many aspects to consider, starting from being proactive and accurate on the same time, and it really affects the smart city management in different countries, and it's one of the main attributes that should be considered when we implement the smart city with the digital twinning aspects. That's in terms of revenue growth and in terms of a different business value. Now we have what we call it the digital twin capability periodic table, the CPT, which is an architecture that will work and take whatever tools and whatever phases we talked about in the previous phase into the action phase. We'll talk about it on maybe some later sessions in more details. But in general, it's an architecture and technology agnostic requirement framework, which aimed to help you design, develop, and deploy, and for sure operate the digital twin in different use cases with different phases and with different capabilities. And this is very important. As you can see, the CPT is not contradicting with whatever we suggest as initial digital twin architecture or phases to move along with the different industries, but it will enhance based on capabilities, and this is very important aspect that we need to consider when we build this digital twin. As you can see, we are talking about the data service capabilities here, the integration service, the intelligence service capabilities, the user experience capability for sure, and the trustworthiness to cover the security aspect in general, and then the management, or whatever come between management and governance in one pillar. This CPT will always help you to develop a proper digital solution based on your current capabilities. So, if we want to sum up the utilization of digital twinning by CPT, we can take the phases as a baby and surely step, starting from implementing AIMA, then building an initial architecture, then having a proper action plan with the CPT model, or the capability periodic table of digital twinning, or the CPT of cognitive digital twinning. And if we want to emphasize on the main parts of the CPT digital twinning, we can go along with data service, which will consider anything related to data integration, whatever related to the API and integration between different system, or maybe different digital twins, the intelligence, and what will come along with the intelligence part of the data analytics, or the action, as we said in our last phase, with the phases of digital twinning. User experience, and the way we are dealing with the user experience, for sure, as we said, standardization and security will always come along to build this ecosystem with a secure manner, and then the management and governance in general. Now, a question we need to ask when we implement a feature development on our cognitive environment, in order to implement the potential of indicative use for such technology, and to provide a framework to facilitate collaboration and multidisciplinary fusion teams with the requirement and specification. We need to have a proper team that will work on what is digital twin for our organization, and what characterize it. Why should I care about having different use cases, library, application, and benefits for my organization? How I should get started with the CPT and with AIMA in general. This methodology has been implemented through ANSYS, through Autodesk, Bentley, Dell, Johnson Control, and some other top organizations around the world, and they are using it to develop their internal cognitive environment in general. Now, just to have a look at, or a deep look on the CPT, as you can see on the left top, we start talking about the data ingestions, the data streaming. The whole pillar is talking about data. Then we went to the management, starting from device management, event logging, system monitoring, data governance. Then on top of it, we talk about the edge AI, and the simulations, and the importance of technology intelligence. Then we talked about the security layer with respect of the five pillars we already discussed in the initial architecture that we provide. And we talk about all the related matters regarding the augmentation, or how to visualize data in general, or we call it the customer journey or customer happiness layer. Now, in each and every box of these boxes that we discussed, we can see three main attributes that will be defined under each and every box. For sure, we are talking about the implementation phase now, and it's very important. We're going to talk about what it does describe exactly. For example, for as a sake of argument here, we put the edge AI and intelligence, its ability to make decisions. So we need to identify it, identify the capability type. Then we go to the outcome and the purpose of such capability. The purpose is to make a real-time decision near fields. Clusters, we have three different type of clusters that we need to consider. Either it's a core cluster, or enhanced cluster, or specialist cluster. Each and every cluster will draw a set of actions that will come along with each and every artifact mentioned in the capabilities and boxes in the periodic table. The capability life cycle, it doesn't differ from our previous phases that we already discussed. Just break down more whatever we discussed from as to plan, to as design, to construct, to commissioning, to operate, to maintain, and retire. And this ecosystem will always provide the assets, the systems, and the processes with an integrative role to connect the data with the integration, with the intelligence, with the user interface management, and with the security. These layers will come along to build and to build and operate and implement the digital twin in general. As you can see, if you see the phases: plan, design, construct, commission, operate, maintain, retire, it's same as the previous mentioned phases, but with different name. But the actions, type of actions that will be taken, it's breaking down more here in general. In summary, the ultimate vision for the digital twin is to know what to reflect on a real time basis in a virtual environment or in a mixed environment or extended environment. The digital twin may drive tangible value for companies to create a new revenue streams and to help them answer key strategic questions with the new technology capabilities such as flexibility, agility, and lower costs. Companies may be able to start their journey to create a digital twin with lower capital investment and shorter time to value than ever before. A digital twin, as we discussed, has many applications across the life cycle of a product or industry, and may answer different questions in a real time basis that we not used to answer or couldn't answer this type of questions before, which always provide a kind of value consideration near the high level of reality or competent level of reality, which will drive our decision in general. And we always need to work on a biggest value using this technology to shorten amount of investment or in a low level of investment due to different opportunities that we have in this technology. Now, to wrap up, we start by defining the changes in the cognitive environment, how we can connect this cognitive environment, and we answered the question of connecting each and every pillar with each other and how it will affect the reflection of having a copy of your physical activities. Then we moved along and we talked about the type and components of the transformation process. Start from the three main processes to the two streams of processes. Then we talked about the different phases that we need to consider, and we summarize the main activities we need to take in the platforms and ecosystem of digital twin. We moved along with the effective phases that need to be considered when we move from step to another in the digital twinning, and what needs to be used in the digital twinning. Then we start using AMA and CPT to finalize the activities of digital twinning and to achieve the required value proposition. Then we explained how we preposition the value for the digital twinning in general, and how it achieve different value aspects according to the certain objective that we already identified in the analysis phase. I would like to draw this opportunity to thank TEDRA Virtual Academy again for such opportunity to explain a very fundamental identifications of what is digital twin, what is the main phases of digital twin, how we can build a value proposition through digital twin, and what is the main aspects of digital twin. Thanks a lot for this opportunity, TEDRA Virtual Academy, and for sure we're gonna meet in some other parts talking about the digital twin